All right. Well, good morning, everyone. Welcome to another session of the 69th Annual Utah State Historical Society Conference. Just a reminder that this session is being recorded along with other sessions and will be made available on our YouTube channel, which can be accessed on our web pages at history.utah.gov or ushs.utah.gov. This morning's session will run until approximately 11 a.m. Mountain Time. And our speaker today, Dr. Logan Mitchell, has agreed to field any questions. So if you have questions, please enter those in the Q&A box at the bottom of your Zoom screen, and we'll make sure that we get to those at the end of the hour. For those of you who are tuning in to Facebook Live, which we're also streaming this session on, we're also monitoring questions on that platform. So I want to move to the next slide here. I want to thank our sponsors this year for our conference, our sister division, the Utah Division of Arts and Museums, our parent organization, the Utah Department of Cultural and Community Engagement, and then our partners, community partners, Utah Humanities and Utah Westerners. A big thank you to all of them for their support. So today we have a treat. I've been really looking forward to this session, as I think many of us have. It's called The Untold History of Air Quality in Utah. And Dr. Logan Mitchell is a research assistant professor in the Department of Atmospheric Sciences at the University of Utah. And I understand he's a member of the Land Atmosphere Interactions Research Group, or LAIR, at the University of Utah. I hope that he talks more about his general research. I know he does research on air quality and greenhouse gas emissions, but came to this this historical topic on air quality in Utah serendipitously, perhaps. And we're fortunate that he's done that, because although some work has been done on smoke abatement early in the 20th century and in the 1940s, and maybe some other historical research on air, not really very much has been done. And so what he's doing is important work that I think we all should be interested in. And of course, it addresses a very pressing issue that we all face along the Wasatch Front, and when we're talking about smoke, throughout the West more generally. So with that, Logan, I'm going to turn it over to you, and thanks again for being here.
Thanks, Jed, for the invitation. I'm really excited to be here. Let me share my screen here. So yeah, as Jed was just mentioning, I'm at the University of Utah in Atmospheric Sciences. My kind of day job is I put instruments on different platforms. We have instruments on tracks, trains, and buses, and we're looking at the spatial patterns of air quality across the city, and also looking at the patterns of greenhouse gas emissions. And I started looking into kind of when did people really get interested in air quality about 1.5 years ago. And I found there's all of this information that's out there that's really fascinating, but it hasn't really been compiled into one spot. And so that's kind of been what I've been working on. So as everybody knows, we have an air quality issue here along the Wasatch Front. There's about 40 days of the year on average that we have in Utah that we exceed federal air quality standards. And generally about half of those occur in the wintertime and half of them occur in the summertime. The last few years, we've had a lot more days in the summertime that have had wildfire smoke. We've exceeded federal air quality standards due to wildfire smoke. So that's kind of an emerging challenge that we have. But in general, our air quality issues are a combination of factors, from emissions that we generate locally and also around the world, the topography that we have here, the meteorology that we have, and the chemistry. But really, why do we care? We care about the impacts on our health. And this is kind of a summary of all of the health impacts from different air pollutants, organized by different body systems. This is a paper we published earlier this year. And in the red bolded things, that they are indicating studies that have actually been in Utah. And it really shows the contribution that the scientific community studying health impacts of air quality shows how much Utah has contributed to that body of literature. And we also know that people care about it. This is Envision Utah did a values study in 2014 that showed that air quality is one of the top 3 concerns of Utahns. And then when they asked people the performance on that priority, it was dead last. And so it shows there's frustration and a desire for policies to address this issue. And it wasn't just in 2014. There have since been many surveys of public opinion showing that air quality is the top 2 or 3 issues among Utahns. So some of my motivating questions were, this is a challenge that we understand today, and it's a prominent public concern, but when did that start to register as an area of public concern? And how has air quality been addressed in the past? And also, since I'm a scientist, I was curious, how did the scientific understanding of air quality evolve over time in Utah and around the country and around the world? And did Utah play a role in the national conversation on air quality? And also, critically, what is our future? And how can our past inform our future of air quality? So as I started looking into this, I found this wealth of information. I'll go through all of these different things. But this is kind of just an overall broad timeline. There's so much that Utah has contributed to the air quality discussion. And it's actually really fascinating. One of my hopes from this project is that other people who are listening and who might have an area of knowledge will look into this as well and start to help fill this out, because I feel like I've gotten kind of most of the broad strokes of this, but there is so much more information about our history concerning air quality that could be talked about. So thinking about air quality, you have to think about our energy system and how that has changed in the past. And if we start in the 1850s, the pioneers, the energy consumption at that time was dominated by wood burning and a little bit by coal. And there's actually this fantastic quote from Brigham Young in one of his presentations. This is from 1860, and it's just really it points to the importance of this issue all the way back to kind of the earliest settlers in Utah. And the quote is, "What constitutes health, wealth, joy, and peace in the first place? Good, pure air is the greatest sustainer of animal life." And the context of what he's talking about is having well-ventilated homes, especially in rooms that are sleeping, because if you don't have a good chimney, you're going to trap your emissions inside the house, and people, died because of that. And so they're recognizing the importance of indoor air quality all the way back in 1860, which is actually really interesting, because today there's starting to be a lot more research about how natural gas combustion in the home can lead to poor air quality inside houses. And so we're starting to still get an understanding of indoor air quality even today. As time went on, and as the city became more developed and there's more industry, the pollution challenges became worse. And there's really the public interest started to ramp up in the 1880s. And this is an excerpt from an editorial in the Deseret Evening News in 1881. And I think the what's really interesting is to think about how they're talking about this challenge. Salt Lake's beginning to suffer from a smoke nuisance. And that's how they talked about air pollution. That's the terminology for air pollution back in the day. Because when you see a smokestack, when a boiler is operating well, it doesn't produce much smoke. But if you aren't operating at the right temperature, if it's not hot enough, you see a bunch of smoke being emitted, and so that's the air pollution that they're thinking about. So they said the time is not far distant when some regulation might have to be adopted or enforced to abate this smoke nuisance. But wouldn't it be just as well if those businesses that require the use of coal in large quantities look about for some remedy of the excessive smoke, and of their own volition avoid the necessity of regulations and declaring their works a public nuisance? So even back then, the thought pattern is, private industry should address this before we should try to regulate it. And it's really striking how similar that is today. But nevertheless, the problem was not addressed, and it continued to get worse. And so in 1891, Salt Lake City passed its first air quality ordinance. And this is the actual ordinance, smoke emitted from chimneys. And what's really interesting to me to note is that in 1891, of course, that's 5 years before Utah became a state. So therefore, Utah has had air quality regulations on the books for the entire history of the state. And just as for a reference, what the penalty for it was a misdemeanor if you're emitting excessive smoke, and it's a $5 to $50 fine per day, which in today's dollars would be about $150 to $1,500 per day if you're emitting too much air pollution. And the focus was on installing these smoke consumers, which are, things that could make your boiler operate more efficiently, that would emit less air pollution. In 1893, I found this really interesting article. This is the first time that they were really discussing the impact of meteorology on air pollution. And they were thinking about where to build factories. And I think it's really funny to note those who are conversant with air currents. That would be a meteorologist back in the day. The understanding at the time was, smoke never crosses a river. And so the place to locate all of the factories west of the Jordan. And so they're thinking, let's put the factories a little bit away from the city. Let's use kind of the natural meteorology of the area to reduce impacts of air pollution. But it's interesting, this justification. Factories that blacken the city with smoke can be as much of a detriment as they are an advantage, for Salt Lake City has much to expect from the increase she'll receive from persons who select it for their residence on account of its pure air and cleanliness, as it has to gain from factories. So already back in the 1890s, they're trying to balance economic growth with environmental impacts and our desire for pure air and cleanliness. But what is really interesting is these decisions that were made back in the 1890s reverberate all the way through time to today. And right now, that's where west of the Jordan River is where the Rose Park neighborhood is, and that's where we have a lot of environmental justice challenges today. And I'll note that it's not just that, but it's the air pollution that was or the selection of those places as factories contributed to the redlining that happened in the 1940s. And it also contributes to, where there's the racial spatial pattern of today. And there's many other people that could speak much more eloquently about the history of that than I can, but I think it's just interesting to make those connections between urban development patterns, racism, and the current makeup of our city. In the early 1900s, there was a lot of conflict about smelters. Those smelters at the time didn't have any pollution controls, and they emitted all sorts of really toxic chemicals: lead, arsenic, sulfur dioxide, etc. And what was happening is that the crops that were adjacent to the smelters were getting killed. And so farmers banded together and they actually sued the smelters for the impacts on their livelihood. And they created this conflict. The smelters accused the farmers of being bad at farming, and ultimately went to federal court. And there was a major case that was decided in 1907 that was decided in favor of the farmers. And eventually this forced many of the smelters to leave Salt Lake, and some of them moved to Tool. Some of them did stay in Salt Lake, but they installed some of the first pollution controls to capture some of those emissions. This is a political cartoon from that time. And it's smelters that are about to move, and this is kind of accusing some of the Mormon farmers of being bad at farming, and kind of the joke is, say, Brother Joseph, do I have to farm my farm now? And so this is accusing farmers of actually not farming, just trying to. They called it smoke farming. So a farmer would just buy a plot of land and not be good at farming, not try to farm, they would just sue the smelters. One interesting tangent of this is that the smelters actually funded a lot of agricultural research into farming practices, because they were trying to prove that the farmers were not good at growing crops. But this led to all sorts of advances in farming sciences, and this may have impacted national farming practices as part of the Green Revolution, that led to a huge increase in agricultural productivity. So it's an example of kind of a silver lining of this conflict maybe having a benefit to broader society. In 1912, the Salt Lake Telegram, which is the previous version of the Salt Lake Tribune, published a 6-part investigative series on air quality. They linked air pollution to health impacts and economic impacts. They were noting that outdoor markets were getting damaged from the soot fall, libraries were impacted, laundry costs. These are negative externalities in economic speak, negative impacts experienced from air pollution that the polluters were not paying for. And in addition, a lot of this air pollution was being caused by incomplete combustion, which is really just wasted fuel. And so it's really surprising to me, they basically had all the information they needed to really understand the scope of this problem in 1912. What they didn't have was access to alternative sources of energy that didn't produce pollution. Around this time, coal-fired power became really dominant, especially for home heating. And so that was really the major focus of the air pollution, the source of the air pollution. In 1914, the Utah legislature created the metallurgical department at the University of Utah. And this is really interesting to me because I sit in the Department of Atmospheric Sciences, but I'm in the College of Mines and Earth Sciences. And it's interesting to me because, it seems like it's a funny mix of college and departments, but actually back in 1914, all of that college was originally created to address air quality issues. And so it makes actually a lot of sense. And I think these headlines are fascinating. Metallurgists to attack Zion smoke. And the goal here was to do research to find a foolproof fuel that burned more efficiently and didn't create air pollution. And so there's many stories about this era. There's also a lot of activism going on at this time. Women's groups got together, organized, and of course, women's groups were organized around a lot of different issues, but air quality was one of the issues that generated a lot of concern and a lot of activity. In the 19-teens, they collected data on best practices from other cities around the US and the world, made leaflets, distributed them across the city. They passed many ordinances across Utah. They gathered in groups. This is the Ladies Literary Club. Were present at public meetings to urge passage of ordinances. And I like this quote here. It's the meeting waxed exceedingly warm at times because there was a lot of concern. This is a big issue for folks. And I also think it's interesting to note some of the headlines. Wage war on smoke. So this kind of the terminology of waging war is used all the way back then. And they formed a smoke abatement league, and there was a lot of activity going on. In 1919 to 1920, the first major study of air pollution of anywhere in the US occurred in Salt Lake City. Salt Lake was chosen because it was a prime example of a city that had a persistent air quality challenge. It was a mid-sized city, and it was a really comprehensive study. It was they looked at the fuel quality, they created emissions inventory, they looked at different sectors, they did smoke air quality monitoring. The first meteorological study looked at health and environmental impacts and made recommendations. And this is the preface of one of the reports that was published, and it's just really surprising to me, keeping the air clean is a product of similar magnitude to keeping streets clean, providing clean water, removing city waste, and guarding the moral atmosphere. There's really this sense that this is a really important priority. And they noted that continuous, never-ceasing effort is required to clean up a smoky city. A few months of relaxation of some years of effort are canceled. And it seems to me that that same mentality is true all the way through time to today. We have to, if you stop focusing on this issue, then the emissions will start to creep back up and things can get worse. And so just as an example of the way they were looking at this, they were using these things called RingoMin Charts to look at the visual opacity of smoke emissions. So on the bottom, you can see what the charts actually look like. And the way it works is you hold one of these charts up against a smokestack and you see how opaque the plume is. And so they give some examples of a clean stack and number 1, number 2, number 3, up to number 5. And you can see how number 5, you basically can't see through the smokestack at all. And this same approach to air quality monitoring has carried through to today. In counties around Utah, you can actually report vehicles that are smoking excessively. So if there's a truck that's rolling coal and you see a black cloud of smoke coming out of it, you can actually report. If you collect the license plate, you can report them. But that system is all based on this opacity designation for air quality. And this study showed there were some scientific measurements of air quality, and it showed extremely bad air quality, stuff that would be just astronomical to today's standards. The sulfur dioxide averaged 150 parts per billion. Today, the National Ambient Air Quality Standards is 75, so that's twice as bad as what the air quality standards are today. And now today, since we've removed most of the coal combustion in the Salt Lake Valley anyways, our measurements today average about 1 part per billion. So it's 150 times worse than it is today for that pollutant. Total suspended particles were 2.5 milligrams, which is, today we measured in micrograms, so that would be 2,500 micrograms. And it's just, they also measured, the particulates in terms of total soot fall. It's just kind of a fascinating measurement. They would put jars out around the city, and then after the winter was over, they'd come back and they'd weigh the jars, and the total solids, the junk that's in the air that has fallen out in the railroad and industrial part of the town is 1,000 tons per square mile, which is just an astronomical amount of mass that's falling out of the air and being collected in jars. And then what they did is they actually combusted that as well to figure out how much of that had fallen out of the air was uncombusted material. And they found it's 50% in the railroads and down to 30% in residential areas. But a huge percentage of that is just uncombusted fuel from inefficient combustion practices. And there was one really fun study that they did that is near and dear to my heart, because we're right now working on a project to use an aircraft to study the chemistry of particulate matter in the air. But already in 1919, they essentially did a very similar study. In Salt Lake City at the time, there was this hypothesis that people thought that the smelters were emitting sulfur dioxide and creating a, quote, a heavy blanket that prevents the air pollution from mixing out. They didn't understand that there was an inversion, a temperature gradient that was actually creating a barrier to mixing. They thought it was actually the sulfur dioxide. And the scientists at the time said, this is preposterous. It's definitely not the case, but are there measurements that we could do that to prove that? And so they got in a biplane and they took these flasks in the biplane and they flew through the inversion and opened their flasks up to different altitudes and showed that there was not a layer of sulfur dioxide that was preventing the mixing. They still didn't understand what an inversion was at that point, but they could show that it wasn't the sulfur dioxide. And so again, this is interesting that the parallels to today, in surveys, most folks think that the factories, mines are the biggest contributor to our air pollution, but actually the biggest contributors to today's air pollution are cars and homes. And so it's interesting to see the parallels with today. In the 1930s, the Great Depression occurred, and efforts to control air pollution decreased because there was obviously another focus. There were some smoke monitoring jobs as part of the New Deal in the late 30s, and in the 1940s, conditions continued to get worse. In 1941, there was a really interesting period of time where there was a really concerted effort to pass more ordinances, and this is just the front page of the Salt Lake Telegram and March 1st, 1941. Of course, it's interesting to see the interest in the focus on Nazis, and that conflict overseas, but also on the same front page you see the smoke density charts show that the Salt Lake problem with air quality has never been solved, and they have these smoke density charts that they were tracking for a couple of decades at that point, showing that the smoke density was, and the air quality has been consistently bad. They even ran today's smoke kind of editorials or pictographs showing the air pollution conditions for the day, and that's very similar to what the Salt Lake Tribune is still running today, with where they have the air quality index for the day that runs every day in the paper. During World War II, when the U.S. joined the war effort, the focus really was on industrial mobilization, and and rightly so. That was a really big conflict, and that's really important, but it did lead to worse air quality. And one of the really key pieces of evidence from that time is the visibility from the Salt Lake City airport. And this is the number of hours with less than 3 miles of visibility due to smoke, due to air pollution. And you can see that during the war effort, the number of hours increased dramatically. And then as the war effort tailed off, the pollution controls came back into place, and air pollution got quite a bit better, maybe even slightly better than it was in the 1930s. In the 1950s, that's when regular weather balloon launches started at the Salt Lake City airport. And along with those weather balloons, that's when you can start to make vertical measurements of temperature. And that was really a key insight to understand, what inversion was and how common they were in Salt Lake City. And so these are some figures from a master's thesis from Doug Dixon. And these were some of the initial scientific studies of what a temperature inversion is in places. And for those of you who don't know, temperature should decrease as you go up in the atmosphere. That's why when you go up to the top of the mountains, it's colder than when you're kind of at the bottom of the city. But during inversions, you get an area where it's actually getting warmer as you get up in altitude, and that's what actually physically traps air pollutants near the ground. And so, this really started to solidify our understanding of how the physical processes that were contributing to higher levels of air pollution. In 1962, the state of Utah commissioned this report. This is the first major state-led study looking at the air resources of Utah. And so this summarizes the research of air pollution. Is actually very comprehensive. It's a fantastic report. And they were, some of the monitoring was related to nuclear fallout concerns. But towards the end of the report, they kind of concluded that there wasn't enough continuous data to really understand. Even though they actually did understand the problem, they wanted more data. And so they decided to collect more information before kind of taking state level action. At around that same time, this is when a lot of the focus of addressing air pollution shifted to the national stage. The Cleaner Act the first Cleaner Act was passed in 1963, and the Motor Vehicle Control Act of 1965, that's the first regulation of vehicles, of emissions from vehicles, and that's what led to the invention of the catalytic converter that started to actually reduce a lot of vehicle emissions. And you can see this reflected with the different sources of pollution. You can see that coal actually started to level off during this time, and really petroleum and natural gas really started to ramp up. And that became a dominant source of pollution in cities across the US and across the world, but especially in Utah. And this is an editorial from 1966 from the Bountiful Mayor. And this is when I found this, I about fell out of my chair. The electric automobile for clean, quiet, efficient urban transportation is the subject of sharply increased interest these days as a means of combating air pollution, noise, and traffic congestion. So already, even back in the 1960s, there was a recognition that our future was going to involve electric vehicles and electrifying transport and electrifying other sources of energy. This is the Electrovare, was the vehicle. Here's what it actually looked like. GM was developing in 1966. The article says that it can travel up to speeds of up to 80 miles an hour, have a range of 100 miles. It's sufficient for commuting and shopping, and so it's really amazing. Unfortunately, GM decided to stop that research line and focus on gasoline cars, and they did pick it up in the early 2000s, but then didn't really put a lot of resources to it, and finally today, GM is really starting to pick up the pace, and they've announced that they're going to stop making gas cars by 2035. So just a few decades later. The Clean Air Act amendments was passed in 1970, and that's when air quality standards and regulations went into effect across the country. So these are the performance on air quality standards in Utah in 1970, and most of the details of this you don't really need to focus on, but just look on the right column. The actual concentration of the air quality standards was higher back then. They were less stringent, and so today these would be much stringent. So the number of exceedances in 1970 is kind of a lower bar, and they would be much higher today. But even so, you're seeing tens to hundreds of exceedances of all of these pollutants in 1970. The air quality back then was much worse than it is today. In 1981, the EPA began testing new instruments to measure fine particulate matter, PM25, which is what we all are focused on today. Before then, they were focused on total suspended particles, so anything in the air. And these new instruments that they were testing were just looking at the very fine particles. And so they were testing these instruments in cities around the country, but this is the first data, the first PM2.5 data in Utah. And so this shows the winter of 81 to 82, and you can see the current day 24-hour requirement is 35 micrograms per meter cubed, and so you're seeing several exceedances. These were measured once every 6 days, but so this would be, still quite a bad inversion season for Utah. In another thing that was had significance nationally was in Utah in 1986 to 87, there was a labor strike that closed the Geneva Steel mill for about 1 year. And when it reopened, there was a lot of focus on, hey, this new plant is belching smoke, and there was Dr. Arden Pope at BYU looked into it and found that there was this really strong correlation between the level of particulate matter and childhood health impacts. And so this is the front page of the Daily Herald in 1987. This is the first day that the Geneva Steel plant turned back on. And Geneva belches back to life with plume of smoke. This is a really big issue at the time. Looking at the comments, the letters to the editor in the Daily Herald, there were comments every single day about Geneva Steel, both people upset about the air pollution and people supportive of the jobs that were being created by the steel plant. In 1990, Governor Bangerter commissioned another study on clean air, and this one actually made 146 legislative and budget recommendations to address air quality. And it set the policy direction for the following decades. But what was really interesting is at the beginning of this report, they laid out kind of 3 large-scale options that Utah has. The first option is Utah could do nothing and allow air pollution to increase. And of course, this would have no costs, but direct costs, but there's lots of indirect costs in terms of the negative externalities, the disease, the medical costs, the loss of income from property and property value. But they note that since this policy option violates federal law, lawsuits and sanctions can be expected. And basically that's not really an option because it violates the law. The second option is to maintain current or slightly reduce air pollution levels as mandated by the federal government. We're just going to follow the federal guidelines, and we're not going to do anything more than that. And this is more or less what has been done for the last 3 decades. This has been kind of the policy direction that Utah has followed. But they also noted that there's a third option. Utah could try to reduce pollutant levels significantly below the health standards set by federal agencies. And they note that in the long term, this option would cost significantly less than either of the other 2 options because of these negative externalities, the benefits that would occur because of better health and less direct cost to the consumer. And it's only achievable if the state of Utah has the political will and creativity to accomplish it. At the time, though, one of the challenges was the technology that was available. They started to look at what would it take to actually pursue option 3. And whenever they started looking into the details, they found that there were economic, technical, legal, socioeconomic, and political issues that became really challenging, and compromise became necessary. One example that they list here is, could Utah require all vehicles to be running on natural gas? And like, well, that'd be great, but we don't control the vehicle manufacturers, and we don't even know if we would have enough natural gas to do that. And so it's like it really becomes challenging to do that. And I also wanted to just note the history of the PM25 standard. This is how kind of the federal standard has impacted Utah. The very first time the standard was introduced for fine particulate matter was 1997. And it was introduced at 65 micrograms per meter cubed. In 2006, the EPA is required to every few years adjust, look at the science and adjust the standard. So it was lowered to 35 micrograms per meter cubed in 2006. But you need, so you need 3 years of data before to assess the standard. So in 2009 was literally the first time that Utah could be assessed for the PM25 standard of 35 micrograms. And in 3 years in Utah, we're unable to meet the standard in 2009. And they were given, a non-attainment status, and then that triggered a whole series of activities that the Utah Division of Air Quality have been working on to reduce emissions to get into attainment. And in 2015, there's reclassification. And in 2019, actually, we got our first bit of 3 years of clean data, and one of the clean data determination, which means we're meeting the standard for fine particulate matter. And there's still an ongoing question: was this from actual reduced emission, or was it kind of favorable meteorology? Did we have not a strong inversion for several years in a row, or is it a combination of both? And so as time goes on, we'll see. So some of the lessons that we've learned that I take away from this history is that Utah has more or less had air pollution challenges since before Utah became a state. So it's not a new problem. We've been dealing with this for our entire history. Also, air quality has improved through time. The air quality today is likely better than it has been at any time since probably the mid-1800s. And it demonstrates this idea that environmental stewardship is compatible and perhaps even necessary for economic development. Because if we still had air quality that was as bad as it was then, there would be very few people living here. And we also have seen what has worked and what hasn't worked. There's regulations since the 1970s through the Clean Air Act and then through the EPA have had a huge, have led to huge progress on air pollution. But it probably has limitations. It can only go so far because the federal standards are set at a certain level. And if we want to go beyond that, we can't use a regulatory approach to get beyond the federal air quality standards. Looking forward into the future, one of the things that makes me the most excited and the most optimistic about our future is that for the first time in 170 plus years, we have economically and technically viable solutions to overcome air quality challenges. This is the cheaper prices for wind and solar and electric vehicles. There's net zero buildings that are being produced. There's so much news about really exciting advances in clean energy technology, and the whole world is moving fast in that direction. There's also a huge opportunity for a state like Utah, a conservative state, to lead the country on bipartisan solutions. Utah is a business-friendly state that prioritizes environmental stewardship and sustainable economic growth, and we can see those threads going all the way back to Brigham Young in the 1860s. Clean energy, and technology will address our local air quality challenges as well as the climate challenge that is global and also local. And this is a page out of Governor Cox's One Utah Roadmap, and I've just highlighted all of the parts of his One Utah Roadmap that focus on sustainable growth, and it shows, and this is his page on economic advancement for the state of Utah, and it shows how sustainability and quality growth are really integral into Utah's economic future. And I like this quote from Utah Speaker Brad Wilson. He was talking about clean air, and he said, clean air cuts across political lines. It's not a partisan issue in our state. And I think that's where there's this huge potential for Utah to lead forward on this topic and start to chart a path out of the kind of the conflict that has existed over the last few decades, and really chart a path towards a clean energy future. And I'll also say thanks to some of the funding support that I've gotten for this project. And with that, I'd be happy to answer any questions that have come up.
Thank you very much, Logan. That's terrific. There are lots of threads that we could follow. So I will encourage anyone to submit a question in the Q&A box. We have one from Kristen. Really interesting question and comment. She writes, "It does seem like we have fewer and less severe inversions, making winter air not as bad. Do you feel that climate change is contributing to this? Will summers become the new bad air time of year because of smoke?"
That's a really good question, and the answer to that is to be determined. As the climate changes, there are two factors that could, regarding the wintertime inversions, there are two factors that could cut either way. Because it's warmer, we might have less snow on the ground in northern Utah, which would make our inversions less severe and potentially make the air pollution a little bit less severe. And that, might make it better. Snow is good for other reasons because we all like to have water in the summertime. And so that creates another problem. But for their wintertime inversions, it might make that a little bit better. The flip side is that as the climate changes, global weather patterns are changing. And it's right now, there's not a good understanding of how that's going to play out. And there is some research that some places are going to be winners and losers. And so, for example, there was some analysis looking at Beijing. Beijing also has wintertime inversions, and that contributes to their poor air quality. And it turns out how the jet stream is changing is leading to more high pressure systems over Beijing, which is actually going to make their wintertime inversions worse. And that same thing could happen here in Utah. So there's a lot of different moving pieces. It's climate change is a gigantic global experiment that we're imposing on the global community, and there will be winners and losers in that. But certainly regarding the summertime smoke, that is a trend that's projected to get worse and worse in the future as we have more droughts and as the temperatures continue to warm and as ecosystems change. Fires are a catastrophic incidence of the climate changing and of ecosystem change, and different trees will grow back in areas that have a different climate now.
Mhm. Yeah, thank you, Logan. I have a question about the relationship between scientific studies and direct action via public policy regulations. You mentioned the 1919 scientific study done in Salt Lake City. Can you say more about the response at the state or local level to that study in terms of regulations, maybe public policy? And I'm wondering, did you find that in general, over the course of this 150 years or so, that regulations come in response to the scientists saying, here, we have a problem? Or is there something else that's prompting generally the regulatory actions?
Yeah, so from the 1919 to 1920 study, there was a decade of follow-up. They recommended a lot of policies to be put in place that was along the lines of improving fuel quality, and also there were a lot of recommendations about how to load your boiler. Do you put the coal in first and put the wood on top, or vice versa? And they had all of these and there were also regulations to enforce from your chimney. And what they found was that for the first few years, they were paying to have people go around the city and with these RingoMin charts and look at smokestacks, and that was actually and then they would be able to tell somebody, hey, you're producing a lot of air pollution, and that cut pollution down quite a bit. And then at the end of that decade, in the late 1920s, they ran out of funding for those people to monitor, and they saw an immediate increase in air pollution as soon as the monitoring stopped. And so it just points, and that's where that kind of sense of, if you let down your efforts for just a few months, the problem gets worse again immediately. And I think that that's true today. If you're not monitoring, then you don't know how bad it is, and it's hard to make progress if you don't see it. There's a really interesting interplay between regulations and science and public action, getting to your second question. And it seems like the science can help help to quantify the problem, and generally when people understand how bad it is, they get very convinced that we need to do something about it. And so, but the science operates very slowly, and then regulatory action happens even after that. And so, but it can, the science, quantifying how bad the air quality is can lead to public sentiment saying, hey, we need to address this problem because, hey, it's here in my community and this is how bad it is. And so it's a complex process. But in the end, it's interesting because in the end, the solutions are always the same. It's, reduce emissions, adopt clean energy, and the opportunity is trying to adopt those. The clean energy is going to be adopted across the world in the next couple of decades. And so the opportunity for Utah is to get there first, develop that technology here, and then we can sell it to the rest of the world. Or if we decide we're not going to lead on this issue, then we're just going to let that technology to be developed elsewhere in China or Norway or Germany, and then we'll buy that technology from them. And so that's really the choice that we have before us.
Great. Absent any other questions, I'll ask another one. I was wondering if you could say more about environmental inequalities that you're seeing through the years, through your research. I think it's really interesting that you mentioned in the 1890s, for example, industries are encouraged to relocate or maybe move or establish themselves on the west side of the Jordan River, and that's creating some geographical inequalities. It goes along with what our plenary panelist, Ben Cater, showed on Tuesday, actually. He indicated that once in the 1890s, you start to develop water systems and sanitary systems on the east side, it creates a flood of water that flows down to the west side, creating some health problems there. And so it seems like we're seeing in the 1890s, early 20th century, this development that occurs, creating a divide between the east and the west sides. And maybe that had been present somewhat earlier than that. But yeah, I'm just curious to know what you're seeing in terms of how air pollution plays out differently among different communities, maybe underrepresented groups, as opposed to those who have the luxury of, say, living in Park City or on the East Bench. What would you say about that?
Yeah, it's been a problem. It's not unique to Utah. It's a problem across the U.S. and across the world, that lower income folks and racial minorities live in places that are more exposed to air pollution. And that's true in Salt Lake City and along the Wasatch Front. And it's a really big challenge. And my hope is that as we move forward, and as we change and switch to clean energy, that those places will get a disproportionate boost in their local air quality. And all of a sudden, these challenges, these negative externalities that these communities are bearing will be lifted. Yeah, it's really interesting because there are so many different threads. Air quality is just one of the threads. And as you mentioned, water quality and other environmental challenges that and injustices that have been perpetuated. It's, and that's why, there needs to be a lot more attention paid to this subject, and different folks looking at different components of it, putting the pieces all together is just really important to have an understanding of the overall contribution to environmental injustice issues.
Yeah, there's a lot more we could say about that. I'm going to get to two more questions that we just received, and then we'll close out the session. But Rachel Turek writes, I live in a county without car emission checks. Do you know how many counties are like that? And is the state showing any interest in making a state standard for car emission standards?
I don't know exactly how many counties. I know that Salt Lake County does have car emission checks, but I don't know if there are any others. Maybe Davis does as well. But I don't know of any efforts in the legislature to pass any regulations to address vehicle emissions currently. And there's some discussion of incentivizing clean energy vehicles, but it doesn't seem like they're as far along as they are in other places. We can look, if Utah wants to compete on the international stage, we can look at other countries and as a comparison point, right now Norway is leading the cause for electric vehicle adoption. They're up to, I think, 80% of all new cars now are fully electric. And that's a very cold country. It's also a very long country. There's, you need to be able to travel across the country. And it's because of policies that were put in place. A lot of people say, it's the responsibility of the individual to lead out on these things. But when you go to buy a new car and you walk on the car lot and all of the cars are gas, it's really hard to make a decision to buy an electric vehicle. Or if there's one car that's electric versus all of the rest of them that are gas. And so we really need policy to adjust and make it more economically competitive to adopt clean energy vehicles.
Logan, we do have another comment from an anonymous attendee that there's pending legislation for the Utah's 2022 session, and he or she's wondering about its potential effectiveness. It's a vehicle emissions reduction program, if you know anything about that. Then the other comment that this individual makes is also back in the 1880s and turn of the century, there were commonalities between poor sanitation and below standard air quality, and wondering if one impacted the other.
I don't know the specifics of that bill. This right now, we're in between legislative sessions, and so a lot of bills are being worked on, and some of them will come up for a vote and some of them won't. And they're continually being modified. But there's, there obviously, could be a lot more to be done on clean vehicles. I don't know. I think the other question was about, is there a correlation between sanitation and air quality? I don't know the answer to that. That would take a bit more digging to find out and see what those parallels might be.
So if nothing else, this has hopefully spurred many of you attending and listening in to take up the baton and do additional research. Logan, you've really outlined this for us well, and appreciate your work on this and for presenting at our conference. And thank you to all of you who are tuning in. So we're going to close the session with that. And I just want to remind folks that we do have a session coming up. It's folk medicine and folk healing and the Latter-day Saint tradition. That starts at noon. And then we have a couple of other sessions in the afternoon. And then we also have, of course, our keynote address tomorrow with Dr. Deidre Cooper Owens. So hope you all tune in for that. And thank you once again.
Thank you.